All right. We're going to do another one-dimensional motion problem. But this time, I'm standing on a cliff. Okay, I'm standing on a cliff. I'm going to toss the ball up. It's going to reach a height, and it's going to just miss the edge of the cliff, and it's going to come to the ground. We're going to send it off with an initial velocity of 2 meters per second. We're going to start our timer, and we're going to time this little cliff, and it's going to take, we're going to measure the time that it takes to fall, and we're going to say that it takes 3.75 seconds to hit the ground. So the time from here to here, it's going to hit the ground. Some things we know, we can use our equations of motion. Because we have a constant acceleration. And the constant acceleration that we have is going to be gravity. It's going to go down, and we're going to use 9.81 meters per second squared. Now, this is one of the tricky parts when we work these problems, because if we're doing things in the y direction, we always will have gravity, but the problem may not articulate that. Problem may not tell us that, oh yeah, by the way, you got to use gravity. But we're also going in the downward direction. So one of the things I'm going to do here is, because we're using gravity and gravity's in the downward direction, I'm going to rewrite my equations of motion to account for gravity. So now my change in height is going to equal my initial velocity times time minus 1/2 gravity times time squared. My final velocity is going to equal my initial velocity minus gravity times time. And my final velocity is going to equal squared minus 2g times my change in y. And we can actually use this as an h. So I'm going to go ahead and use this as an h, because that makes a little more sense. And I've rewritten my equations in terms of gravity. Some other things that we know is we actually know what the velocity is at the top. Because remember, things have direction and magnitude. So the instantaneous, right before it gets to the top, it's positive. And just as it comes out the bottom, it's negative. So the velocity at the top is going to be 0 meters per second. Because we're changing direction. We're going to get the 0 meters per second because we're changing direction. So from this type of problem, which you guys have an active example that's very similar to this type of problem, we can ask all kinds of questions. We can ask, what's the height to the top? We can ask what the total height is. We can ask what the velocity at the bottom is. We can ask a lot of different questions given the situation. So we could play with this one for a long time. So we're going to do two parts. We're going to find what's the velocity at the bottom and what's the height that it gets at the top. So let's do the height at the top. Height at the top. I know my initial velocity was 2 meters per second. I know my final velocity is 0 meters per second. I know my acceleration due to gravity is 9.81 meters per second squared, and it's going in that direction. And I want to find h. So let's look at my equations. This one's got gravity. This one's got initial velocity. It's got final velocity. I've got to find h. Woo, that one looks like a good one to do. So I'm going to have final velocity minus my initial velocity is going to equal minus 2gh. H is going to equal v final squared minus v initial squared divided by a negative 2g. So I'm going to go in here and we're going to double check everything. My final velocity is 0. My initial velocity was 2 meters per second, and that's squared, so that's squared and squared. G is negative 2 times 9.81 meters per second squared. I'm only left with meters, so life is really good. The negatives cancel each other out, so that's good. So I'm going to have 4 divided by, well, I'm going to have 2 divided by 9.81. And it's only going to raise up 0.2 meters. That's all right. We're going to solve for the velocity at the bottom. Well, this is good, because I know what my initial velocity is. I want to follow the velocity at the bottom. Oops, but I don't have time. Well, yeah, I do. Because of symmetry, on the way up, that is my initial velocity, but on the way down, this is a negative 2 meters per second squared, or 2 meters per second. So my final velocity is going to be a negative 2 meters per second minus 9.81. And I was given my time as 3.75 seconds. So I've got meters per second squared times seconds. So I'm in meters per second. That's all good. And when it hits the ground, it's going to be traveling at 38.8 meters per second. And it's in the negative direction. So that gives you the start of the problem. I encourage you to do the active example that's very similar to this one, because we're going to play with this type of a problem several different times. I have this type of problem in my videos in a number of different places. So we've got those there.